channel. So in this video I am going to teach you about the magnetic field due to straight current carrying conductor. In last class we have studied the Biot-Savart law. So using that Biot-Savart law we have calculated the magnetic field because of the small element, means because of small current element we have calculated, but in this video we are going to calculate the magnetic field for the complete wire. So let's start. So this is our wire. So this wire, first end we will take it as X and the other end is Y. So in this Y, in this wire I amount of current will be flowing, and this is our point P. At this point we want to calculate the magnetic field. So what we will do means we will represent where the point P is. So for that we will take one perpendicular distance from the wire, and this point P is placed at a distance of A from the wire, and next we will join these two ends. So this angle will take it as phi 1 and this angle will take it as phi 2, and next after that at L distance from this point we will take one current element, small current element, and it is represented as dl, and this distance is L, and now we will join this current element to point P, and now this angle will becomes theta, and this angle will becomes 90 degree because it is perpendicular, and this current element to the point P, the distance will take it as R, and next this angle will take it as how we will get this angle means 90 minus of theta. So this is 90 minus of theta. Next after that what we will do means we will use the Biot-Savart law and we will calculate the magnetic field for this small current element, and after that we will integrate that equation. So when you integrate that equation we will get the magnetic field for the complete wire. So now here I will write, according to Biot-Savart law, according to Biot-Savart's law, what we can write means dB is equals to mu naught divided by 4 pi I into dl sine. Here what theta you will take? Here this is 90 degree, here this is theta, and this is 90 minus theta. What angle we have to take means our answer is always you have to take the angle between current element and the distance vector r. So this is current element and this is the distance vector r. So the angle between these two is 90 minus theta. So here I will write sine of 90 minus theta divided by r square. So this is our Biot-Savart law. So now after that this equation will becomes dB is equals to mu naught divided by 4 pi I into dl sine 90 minus theta. Sine 90 minus theta can be written as cos theta. So this will become cos theta divided by r square. So now this is our magnetic field because of this small current element. Now if you integrate this equation then we will get the magnetic field for complete wire. So we will do the integration, we will apply integration on both sides. So now when we are integrating, this mu naught by 4 pi is constant and this current flowing in this wire is also constant. So all these three terms are constant, so we will write it as outside the integration because constants cannot be integrated. So integration of dB is equals to mu naught divided by 4 pi, this is I, integration of dl cos theta divided by r square. So now we will take the limits as minus phi 2 to plus phi 1. We are applying these limits. Why we are applying the limits means when you take this phi 2 to phi 1, means if you are covering these two angle means we will cover the whole wire. Suppose if you take only phi 1 then we will get the wire only this much length. If you take phi 2 then we will cover this length. But if you cover from phi 2 to phi 1, though if you cover this whole angle means we will cover this whole wire. So because of that we are applying the limit minus phi 2 to phi 1. Next after that dl cannot be integrated with the theta and this theta cannot be integrated with the r because dl is in terms of length and theta is in terms of the angle. So both cannot be integrated, and similarly same theta cannot be integrated with the r. So what we will do means we will convert this dl and r in terms of the theta, and then we will do the integration. So now for that what we will do means we will consider this triangle. So consider this triangle. So in this triangle cos theta can be written as base divided by hypotenuse. So base is a and hypotenuse is r. So we will write it as a divided by r. So next r can be written as r is equals to a divided by cos theta. Similarly again tan theta can be written as perpendicular divided by base. So in this case perpendicular is L and base is A. So here I will write L divided by A. So L can be written as A tan theta. And next if you differentiate this one we will get dl divided by d theta is equals to A sec square theta. So dl is equals to A sec square theta d theta. So now we got the value for the r and the dl. We will substitute this r value here and dl value also we got. So if you substitute these two values in this equation, then we can do the integration. So now we will write db is equals to integration of db is equals to mu naught divided by 4 pi I integration of minus phi 2 and this is phi 1. dl can be written as a sec square theta d theta. A sec square theta d theta and this is cos theta divided by r square can be written as r value how much we got a divided by cos theta. So here I will write a square divided by cos square theta. So now in this case cos square theta and this sec square theta will be cancelled and 1a and this a will be cancelled. So now this equation can be written as integration of db is equals to mu naught divided by 4 pi I integration of 1a is remained. So here I will write it outside and next what is remained cos theta d theta. Cos theta d theta and limit we will apply as minus phi 2 to plus phi 1. So next the same equation can be written as integration of db will becomes b is equals to mu naught divided by 4 pi I divided by a. Integration of cos theta will becomes sin theta. So here I will write integration of cos theta is sin theta and our limits are minus phi 2 plus phi 1. So now this equation will becomes b is equals to mu naught divided by 4 pi I divided by a. We will take first upper limit. In this theta first we will substitute the upper limit, that is phi 1 minus of sin minus phi 2. Next magnetic field B is equals to mu naught divided by 4 pi I divided by a sine of phi 1. Sine of minus theta can be written as minus of sine theta. So minus minus it will becomes plus. So this is plus sine phi 2. So this is the final equation. So this is our final result of magnetic field due to complete wire. So this is all about magnetic field due to a straight current carrying conductor. So if you substitute the phi 1 and phi 2 value, then we will get the total magnetic field. Means here suppose if this angle is 30 degree and this is 60 degree. So if you substitute those values phi 1 phi 2 value in that equation, then you will get the magnetic field. So in next class we will calculate for the infinite length of the wire. So stay tuned.